Geometry, Chapter 3 review. We're going to go on to problem number 9. Now, in problem 9, we've got to find the value of x that makes m parallel to n. I'm going to actually do 9 right here on this paper. These guys are consecutive interiors, so I know because they're consecutive interiors that they have to add to 180. And so this is actually a pretty simple problem. 180 minus the 73 is going to tell me that angle x is 107 degrees. Once I know that those two angles add to 180, I can assume that M and N lines are parallel to each other. Now, number 10, I think I can do my work for 10 here. If these alternate exteriors are congruent to each other, that'll say that M is equal to N. I'm going to set these equal and just solve for x. When I take 14 away from both sides, x is equal to, what is it? 133? Cool, thank you. So that one was that alternate exterior idea. Consecutive interior, just for practice, alternate exterior. You'll have to justify some, so we're just going to label them up here. Now, I don't have any relationship between where this 2x plus 20 sits and where this 3x sits, because the 2x plus 20 is on an interior angle and 3x is out here on an exterior angle. So the one thing that I can do though is if I consider 3x to be the same measure for its vertical angle inside here, I can put the 3x up in there and I can then say, all right, 2x plus 20 plus 3x has got to be 180 because I've put those in as consecutive angles. So that's going to take me to, I'm going to move over to the side of my paper. When I simplify the left side, simplify the left side, 2x and 3x is going to give me 5x plus the 20 equals 180. I'm going to take the 20 away from both sides. 5x is 160. When I divide both sides by 5, x is going to be 32. I used consecutive interiors, I used vertical angles, and then consecutive interiors on this one. Number 12, these guys are corresponding angles. They are sitting in the same position related to the transversal.
Please pardon the interruption. If you are going on the Spanish
I'm going to set these equal to each other.
To room 127 now. If you are going on the Spanish field trip, please report to 127 now. Thank you.
I'm going to choose to start this by taking 3x's away from both sides. 4x minus 11 is going to be equal to 58. When I add 11 to both sides, this video will be published later, sweetie. That should have been minus 4. Sorry, listening to that. So this was 3x. There we go. I had the idea in my head that I was going to wind up with 3x. There we go. Take 4x away from both sides, not 3x. Take 4x away, I wind up with 3x. Minus 11 equals 58. So then 3x equals 58 plus 11 is going to give me 69. When I divide 69 by 3, 23. Again, those guys were corresponding angles. Now we go into our proofs with perpendicular lines. We need theorem names and numbers for these. Oh shoot, I had you guys have your notes out. Where's mine? Notes. Yeah. Say it again? So I'm going to just grab my notes and open up to the 3.4 section. The theorems will be on your test. You guys will have access to that. 3.4. So in 3.4 I have theorem 310, which has to do with linear pairs. This one, perpendicular transversals. When we start out with the parallel markings and one right angle, we can assume another right angle. That's theorem 311. Theorem 312, if I've got two right angles at the transversal, I can assume parallelism. So the question is, do I have enough with these drawings? Now with number 13, if I know that this angle is right, so is this one. I actually have right angles all the way around, but the reason that I'm going to this direction is because then I know that those two perpendicular angles are going to make x parallel to y by, that is the Theorem 312. If two lines are perpendicular to the same line, then they're parallel to each other. So by theorem 312. Now in number 14, I have a 90-degree angle. I have a 90-degree angle. Let's see here. I don't have 90-degree angles on the same transversal. Like, I don't have a 90-degree angle on X at W, but I have one on Y at W. I'd have to have it both. I have a 90-degree angle on Z at X, but I don't have it on Z on Y. I can go around and talk about other 90-degree angles. There's not enough here. There's not enough info on this one to conclude anything here is parallel. Now, a little less confusing, I can see some 2 angle markings on this one. So let me use different colors here to kind of highlight where I'm going with this. In number 15, if I look at these right angles that I see right here, that lets me conclude, and I'm doing it in green, that M is parallel to N. Okay? M is parallel to N. This is going to be that theorem 312 again. Now, besides that M parallel to N, now I can also go and look at this right angle, and I have another one right here. That's going to make A parallel to B. And that's by theorem 312 as well. I've got those marked. Now I'm looking, can I say that L and M are parallel? I don't have perpendicular markings in the same transversal for L and M. I've already got M and N, but that's all I can do. I can't say L and M are parallel because they don't have a right angle on the same transversal for either of those. Now number 16, let me use color again. If I know that this is 90 degrees, guess what? I also got 90 degrees here. That's going to make A and B parallel. That's theorem 312 again. And I think in that case, that's the only set that I can say is parallel because I don't see where I can have right angles on any other 2 pairs along the same transversal. In the case of 15, we had a transversal. So in 15, the transversal that helped was that one for the orange pair, and the transversal that helped for the green pair was that one. So I have to see the right angles on the same transversal. So that would leave that right there, nothing further. Let's go on to 3, 5, 17. I'm actually going to put this in a new video, so these are a little bit